people don't like rap, then you got other things. This is for no particular reason at all. I just have random music and stuff on my computer to test the sound, because you don't want to like put the sound partway through. And whenever we start, it's up to you. We wait 2 or 3 minutes. That means I get 2 or 3 minutes extra? You want to hear boring stories? Yes? No? Okay, so this is just my dumb story about this music. So my grandmother used to play piano. She used to play this song. That's not her. Her hands look much older. But so when she died, I kept this piano music that no one's ever heard about. And I started trying to buy some, and I couldn't find any. So I posted it online and made a Wikipedia page for it. And then after that, about 6 months later, I started finding copies of it online, like on eBay and stuff. So I think what happens when people's grandmothers die, they search on the internet, and if there's like something in the search results, they'll like put it online to buy. So I started buying up all the copies that people would put online. They're typically like, $5 Canadian, so it's like 12 euro cents. And now I'm the world's largest collector of this completely unknown piece of music. And now you get to hear it too, so completely stupid stories from conferences. And I do a little fat fire to keep Felix happy. Wake you up after lunch. Are you sleeping from lunch or no? No? All right. Now you're not. Yeah? All right. We're going to kill this and get going.
So
all right?
Welcome back, everybody. Hope you had a good lunch. Our next speaker, James Shubin, straight from Canada, working at Red Hat. And yeah, his talk will be about the next generation config management tool, which is Mgmt. Enjoy this talk.
All right. Thank you, everyone. So I hope you don't mind. I'm going to sit down for part of this talk because I want to type. And I speak a little quickly, so if you really lost something and you're really, really confused, let me know. But otherwise, I have a lot of material I want to cover because I want to see what I can do in an hour. Does that sound okay? Yes? Are you confused? Who's really confused? Just let me know right now. We'll start off. So really quickly, my name is James. I work at Red Hat. I work for the storage engineering team now, so I'm helping with automation. And I showed you this video. So who am I? Can you turn down that mic one tiny bit more? Thank you. That's okay. So I'm a hacker. I work on config management stuff, as I said. I write a technical blog called the Technical Blog of James. Who's seen it before? Just raise your hand. If you haven't seen it, just raise your hand anyway, so I seem really popular. Go on. Excellent. Thank you. I'm actually a physiologist by training, so if you want to talk about cardiology, just ping me after. That's what I used to do. And I'm really into DevOps, so I'm going to talk about that. Can you guys still hear me okay? There's a little noise, but that's okay. I think we'll work with it. Anyways, so you might remember some of my Puppet hacks from back in the day. Oh, that sounds a little down. I'll just play that again because it's so good. It's just speakers screaming because everything's on fire. So I did quite a lot of Puppet. Who has no idea what Puppet is, by the way? Don't be shy. Who's shy and really hates raising their hands? Please let me know where you are. Raise your hand. Excellent. So gentleman in the back. So I started hacking with Puppet quite a long time ago. I think I got fairly good at it, and I wanted to really build truly autonomous systems. I wanted to build really powerful infrastructure as code, and I sort of announced this stuff that I was working on in Puppet quite a long time ago. I built some crazy hacks, so you can actually build recursion in Puppet, in the Puppet DSL. You probably don't want to do this, but it was just experimenting how far I can push the tool. The code's at the bottom if you want to look at this. You can build this thing where Puppet runs, and then it double forks an exec process that waits for the main Puppet to quit, and then runs it again, so you can run multiple Puppet runs very quickly. You actually do need to do this when you have more than one system that converges together. You can do this thing where you have timers, which I also built, where you run something, it does double fork, and then this gentleman's like, "You're talking too fast. Slow it down." Sorry, I have so much stuff to show you. I'm going to try and slow down. The good thing is everything I've shown you before is online. I've blogged about this stuff, so if there's some weird thing I missed, you can check it online, and all the material's available. Yeah, so timers, basically you would start, say, a DRBD cluster building, and then it would wait 2 hours for the cluster to converge, and then run Puppet again, that sort of thing. And you can even build finite state machines in Puppet, which is a little bit absurd, but if you want to see how this works, check it out. All of this was really to build more powerful automation. And I sat down and I really sort of had this conversation, is this the right way to do it? Are these hacks inside of Puppet, on top of Puppet, the right way to do things? Anybody? Don't be shy, call it out. Yes, no? We have somebody else. So here's the guy who will answer this for me. He's my friend. He's the nope guy. Have you seen this? So the nope guy. For the video people working, by the way, you don't want to look at me if you're recording. You probably want to see just the slides. So everything fun is going to happen on the screen, and I'm just going to type furiously. So basically, I sat down, and I finally took the time to build what I thought was the correct thing. And now we have a thing called Mgmt. We even have stickers, so if you're really nice and you promise to use them, come, I'll give you a sticker after. But let's really talk about what the tool is about. Skip this stuff. There's three main design points of the tool that are the core to everything, and I'm going to go through and show these one at a time. Does that sound good? I think lunch is still working. Does that sound good? All right, thank you. All right, so there's three main things. The first is the tool runs in parallel, which I'll show you. We're event-driven, so we can respond very quickly and sort of know the current state of things. And we work as a distributed system, which I'm also going to show you. So let's just go over here and show you the first thing. So here's a graph. The blue boxes represent resources. So in Puppet or Chef or any sort of tool, you have a resource, which is a unit of work that you want to do. The black arrows, if you can see them okay, are the dependencies. So that means I want 4 to happen before 5 and 6 and so on. And current tools can only typically run one thing at a time. So if you look very closely, there's this red arrow. And what tools do is they basically do something called a topological sort. And they just run through and they pick one safe path through this graph, since you can only do one thing at a time. So in this case, we do 1, 2, 3, 4, 5, 6, and then 7, just for example. But you could pick a different path. It doesn't matter. Make sense? But the truth is, what we can actually do is if the dependencies are correct, everything on the left can happen at the same time as everything on the right, because there's no dependencies between these two graphs. And 1A here, once this is finished running, 2A and 2B can both run in parallel, and then once they're both finished, 3A can run. Does that make sense? No? Come on, who's shy? Don't be shy. It's going to be fun if you interact with me. Then I'll know if you're really lost and I talk too fast. So do you want to see a demo of this? They're very shy. How do I do it? It's a shy German thing. Okay, sorry about that. All right, fair enough. So I'm going to show you. All right, cool. German hecklers, all right. So I'm going to show you this graph here. We have 3 resources here that each take about 10 seconds to run, and we have one over here that takes 15 seconds to run. So if we run this at the same time, how long is it going to take to run? How long? 10 seconds, 10 seconds, 10 seconds, and then there's another 15-second one here. So yeah, it'll take 30 seconds, right? Because the longest path is the thing that's going to be limiting the whole operation. Now, Mgmt runs continuously, so I can actually ask it to shut down when the graph is converged. So I'm going to run that over here. Is that big enough? Can you see that? I'm going to run this graph, and I have this converged timeout option equals 5. So I can say, hey, when the graph has converged for 5 seconds, shut down. And I'm going to time this whole thing. So we'll see how long it should take. It should take, we said 30 seconds plus 5 for this converged timeout. How long? 35 seconds. Let's run it. So it's just starting up. You can see that 10-second thing and that 15-second thing are both running at the same time. They're both going through. 10 seconds in, we should see the first thing finish. Should happen right about now. And that finishes. That second part finishes running too. 5 seconds after that, which is just coming up. 5 more seconds after, that middle piece is going to finish running, which we'll see at the bottom. And then that last resource at the very bottom, if you can see that, that's starting to run. That's going to go through 6, 7, 8, 9, 10 seconds go by. It finishes. 5 seconds, we expect it to shut down. Let's see if that happens. It does. And the whole thing finished running, in this case, about 37 seconds. So the whole tool is very, very efficient, very, very fast. 2 seconds of overhead in this case. Make sense? I don't know why tools didn't do this before, but we're doing this. So the tool's written in Golang, makes it very, very quick, and I got more stuff to show you if you're interested. Yeah? More demos? Okay, good. So another problem with a lot of current tools is basically they pull. So you run Puppet, it goes through, checks everything, potentially applies a state. We'll start over, go through, do that whole work all over again. Some other tools that we talked about today also pull. And this is fundamentally a problem because if something changed in the middle of those 2 runs, you won't be able to fix it until that run starts again. Or if you want to change something, you'll have to wait till the tool runs or have a way to poke it. So we actually do everything event-driven. So I'll show you a little demo of this because it's much more illustrative. So this is all just running at the moment on my machine. On the right, we just have a folder which is empty. And on the left, I'm going to run this graph. And the graph I'm just going to show you the raw data structure of the graph. just so you see how it runs. It's right here. I basically am going to ask it to create 3 files, F1, F2, and F3. And you can see they have contents, I'm F1, I'm F2, and I'm F3. Okay? Very simple stuff, nothing fancy. The 4th file, F4, says ensure that the state is absent, so do not create this file. Am I blocking the screen with my body in the back? All right. So let's just run this and see how it happens. So we're going to run it on the left, and then I'm going to very quickly go over here to the right and ls, and you can see that basically almost instantly we have the 3 files that got created. You can cat them and see how the contents are there as requested. And the cool thing is if you remove F2, you can list and it's already right back because the agent is running continuously. So you can remove F2 and before I even do something, you don't even notice, it's right back. And it's so quick you can even remove F2 and cat F2 and just even before the second part of the command runs, it's just right there going. Okay? Again, tool very, very efficient. It doesn't have to waste CPU cycles rechecking every time it pulls. And just to show you really that it is quite fast, if anyone knows the watch command, watch just runs something over and over again as fast as it can. So if I just run this, you can see that the tool is buzzing away very, very quickly in this debug mode, and the file is basically always keeping that state, or virtually. Make sense? Do you like this? Cool, so this is the primitive that I think is very, very powerful. And we don't do this just for files. We do this for every kind of resource. Files, packages, services, and even virtual machines, which I'll show you a little bit later. All right? Let's move on. I'm just going to kill this. So that's the event stuff. Lots of different resources. Higher level resources that weren't possible in Puppet and Terraform and all these other tools are now really quite possible. So this is what I think config management, as I like to call it, should have been. Some people think it's a higher level technology, a choreography sort of thing, but I see this as another technology in addition to the automation stuff. What is that technology that I'm thinking of? If we're sort of merging 2 worlds. Anyone? Don't be shy. If you've seen the talk, then don't cheat and tell everyone. I think this is actually a bit like monitoring. So if you think about what a sysadmin or a DevOps person might do, they set up a whole bunch of stuff, they define their infrastructure, and they push to production, right? But no, you shouldn't do that. You have to first set up everything so that it's monitored as well. And you're all good sysadmins and you do this, right? You don't put in, right? You always wait till it's monitored before it goes into production? Yeah, you're all liars. But now, if we can actually build in at the resource level some sort of reporting, that watch stuff, we can actually get a little bit of information about what's going on and to fix things very quickly and maybe tell the user, hey, something has changed state, you should look into this. So it's not a full monitoring story, but it's something that we think adds some value. Any questions? Is anyone really, really lost? Because I want to show you more stuff. Want to see more stuff? We're getting slightly more enthusiastic. All right, so I'm going to show you a few topologies. So this is the first topology where you have a whole bunch of clients that go off and initiate a connection to a server. What's this topology called? Call it out. Client server. Everyone's familiar with this, right? What are some problems with this topology? Anybody? Call it out. Redundancy is missing, so single point of failure. What's another problem with this topology? Load distribution, right? So if you have many, many, many clients, this could be a big problem. This is a very good topology, though. It's a very well understood topology. It's a classical topology. Nothing wrong with it, but it does have some weaknesses. This is what Puppet uses, for example. Not to bash on Puppet, that was what people were doing at the time. Here's a slightly different topology. This is what I call a central orchestrator. So when you call something an orchestrator, as far as I'm concerned, that means de facto, by definition, there's one central point that goes out and initiates connections to, in this case, a bunch of machines. Okay? Make sense? They look very similar, just the arrows are pointing the other way. What are some problems with this topology? Call it out. Oh, you know this, but you're shy. Don't worry, I won't scream at you. What? Yeah, scaling. Still, if you have many, many machines, this can be a bit of a bottleneck. What's another problem with this? Firewalling can be a problem. What's another problem even before firewalling? Yeah, single point of failure. So same problem sort of exist. Here's what we don't do in Mgmt. Here's where every peer connects to every other peer. This quickly doesn't work because you end up having far too many servers and connection counts at n equals 10 or 20 or so on. Here's what we actually do in Mgmt. So in Mgmt, every agent, basically every machine runs this little agent, and they self-assemble into a cluster using the RAF protocol, which is thankfully written by the etcd folks. So thanks, guys. And what they do is this small inner circle that gets elected to form these primary servers, they run Raft, and everyone else is a client that connects to one of these machines. And the really cool thing about this is if one of these central machines dies, that's okay. Another one can be promoted to be a new server. Does that make sense? Now, we do a second cool thing. Now that we have this raft thing running, we can make some distributed consensus decisions quite easily. The other thing we do is we use etcd as a database for temporary storage of some stuff. And we store that in the cluster. That's this database that's highly available that lives among this potentially constantly changing cluster. I'm going to show you a little demo of this. So what I'm going to do here, whoops, I'm just going to go over here. Just going to make some directories. Oops. Okay. And I'm just going to tree. You can see there's 5 directories here that are empty. And I'm just going to watch this whole thing. So on the right, instead of me making 5 VMs, because that would be really slow on my obviously really crappy laptop, I'm just going to create all of these folders so you can pretend they're 5 different machines. Does that make sense? So what I'm going to do is I'm going to start up here. I'm going to start up the first Mgmt. All the commands are doing is I'm running it. I pass it the graph that I want it to run, so it's these directed acyclic graphs. I'm cheating by saying your host name is h1 because we're going to have multiple on the same machine. And these last 2 options are because I'm running in a debug environment. So lots of things break on my machine sometimes. So I'm just going to run this. Now what each machine is going to do, each machine is going to run, and it's going to create one virtual file in the database. Okay, one virtual resource in the database. The second thing it's going to do is it's going to look in the database and it's going to pull down all of the resources that it sees, and hopefully they should appear in this folder. So if I just run one machine, it puts one thing up and pulls everything down. How many things will we see in that folder? Call it out. 1. You're all that shy. You can all count to 1. So let's see this run. You want to see this run? All right, so we'll run this. It starts up. Very quickly, one file appears. Right, this is just watching that directory structure live. Let's do a second thing. We'll start, normally you would just start up all your machines, but I want to show you the process. So let's say I start up a second machine. Same algorithm is going to happen. It puts one thing up in the database and pulls everything down. How many files are you going to see on B? No, the gentleman had it right here, 2, right? So you put one up, there's already one up there, so that there's 2, we pull them both down. But that first machine is also watching this database in real time, and I told it to suck everything down in this particular case. So it's going to get updated as well. Just before I run that, I just want to show you the CLI. Right here, I pointed at the graph, I say that it's H2. All you have to do to automatically cluster these things together is any new machine points to anyone in the cluster, any existing member. So this is the IP address of the first member because there's only one. The other things here are just separate ports because we're all running locally and they would clash with ports otherwise. And so let's just run this. Boom. And in basically under a second, you got 2 machines, both of the 2 files. Does that make sense? Do you want to see a third one? 3? Let's say we add a third one and we do the same algorithm. How many files are we going to see now? On everyone. What? Total, yes, 9. So 3 per machine, right? You put 1 into the database and pull it down. Let's run that. And it's all done. So it converges very, very quickly. You don't have to wait 5 minutes or 10 minutes for the next Puppet run or anything like that. So this is what actually is most similar to Puppet that they call exported resources. We're a little bit different because we work live, but fundamentally the same sort of design. And here's why it's important. Here's an algorithm which I've just described to you, which is something that might happen in a boardroom. Let's say you're going in for a meeting. You go into the boardroom. Everyone basically puts their name into the middle of the table and reads all the names that are already there. So once you get in the room, it's only you in the room, and you already know yourself. Once the second person joins the room, they put their name into the room, and then they see there's 2 names. So we're actually doing a sort of peer exchange to see who's actually a member in this cluster and exchanging data amongst ourselves. Another common pattern you might want to do instead of this algorithm, if you use Mgmt, is suppose you have a whole bunch of web servers and a big load balancer. As each web server starts up, it might actually export some firewall rules, which it puts into the database. The load balancer might be watching that database and sees, oh, there's some firewall rules here. I'm going to pull those down and create those firewall rules, thus opening those ports and those forwarding mechanisms in real time. Does that make sense? So these are the things we want to do. We want to make it easy for you to describe your complex distributed topologies in a tool. I'll show you another really quick demo on this if you want. Is anyone confused on this so far? Or is anyone lost? You have a quick question, sir? No, he'll ask me later. He's shy. But that's okay. He's a colleague, so he's going to be like, hey, ask me, what have you built? I'll just show you one other quick thing. So I can actually even just talk to the cluster manually, and I can say I want there to be, remember over here we had these different servers? I want there to be a maximum of 3 central servers. So I can just tell it that right here, and it's going to say, okay. And now what I'm going to do is I'm going to start up a 4th machine. So I'll just start up. If we start up a 4th, how many are we going to see now, files on each machine? 16 total, that's right. So that works very quickly. They're all 4 running. If we actually now query the cluster membership, we can actually see that there's only 3 central servers and everyone else is a client. Because I said maximum of 3, please. But now, if I change my mind and I say, no, you know what, I changed my mind, I want there to be up to 5 servers maximum, I say okay. Now if I query the membership, you can actually see that through this election process, we've actually promoted that 4th server to be a central core server as well. Okay? So this is sort of an elastic etcd implementation that's built into Mgmt. For the CoreOS gentlemen in the room, this is the sort of thing I wanted to see in core. It's unfortunately not upstream in core, it's in Mgmt, but this is the sort of thing that we want to do because we want the etcd part of the cluster, which is really fundamental, to sort of manage itself automatically. So just some food for thought. That's it for this demo. I've got a few more things if you want to see some more. Yes? Okay. I'm just going to kill this stuff at great speed because I don't want to wait. And then I'm going to show you. Okay. You can actually shut it down cleanly, but I'm short on time. So I've showed you this stuff. You can review this all online. This is my really bad infographic. If you can draw better in like LibreOffice, please help me. I am really bad at this. There's a few more things I want to talk about. I'm going to skip this example. I'm going to show you this a little bit later. Skipping. I'll show you this example. So, sorry, my slides are not in exactly the right order because I kind of change things depending on the audience. When people look really confused, I go faster. You guys don't look really confused, but you look really shy. So I'm going to show you this example. Here is a graph with a bunch of resources. It's not a very pretty graph. There's 3 packages, 2 files, and a service resource. Now, if I were to run this graph on a traditional tool, what would be one of the problems with this graph, or things that suck performance-wise? It's a little bit tricky. Don't worry if you don't get it. What happens? Who's done some Puppet and has run something with a few packages, files, and services? I know you've done package file service. This is like ABCs. Don't be shy. No one? All right, I will tell you. So what will actually happen? As you know, since we can only run one thing at a time, what actually will happen is Puppet will start up. It'll say, okay, I'm going to install this first package. It'll shut down. It'll install the second package, starting up the package manager all over again, which takes a lot of time. So check the caches, check the package DB, shut down, and do the third thing all at the same time. So in Mgmt, we actually have this notion of automatic grouping. It should be a giveaway in the slide title. So what we actually do is we analyze this graph at runtime dynamically, and since this graph is actually functionally equivalent to this graph, we do this rearrangement, and now these 3 packages are actually grouped into a single resource. So now we can perform that operation as a single step, install these 3 packages, and this happens very, very quickly. Does that make sense? We can do this for any resource primitive that supports it. So let me show you a quick demo. Oops, let me just see, auto group. So I think this is the demo. So my password is password if you're listening at home. So I'm just running this graph. It has those 3 things. It's not as flashy as the demo, but if you look closely, you can see that it did this auto group thing, and you can see Cowsay, PowerTop, and SL are all being installed or checked at the right time. So we can just check if Cowsay is working. Hey, Cowsay is working, that's good. We can say, hey, NETWAYS, that's good too. Now we can actually, if we want, just to show you, let's remove Cowsay. I know this is bad, but we're just going to remove Cowsay. Yes. Let's hope the internet works. If this doesn't, it will be less exciting of a demo. So it's removing Cowsay. And if you notice, Mgmt right here saw that it got removed, and it quickly went and moved it, installed it right back. And Cowsay, hey, it is back. Cool? So same thing. The packages also have this event system, and if you change the state, or if, as the user, you request a new state, it fixes it right away. Make sense? I just like doing this because I'm a weird nerd. You can even Cowsay inside of Cowsay if you've never done this, and you can do this like crazy. So if you want to have something fun to play with and you hate my software, at least enjoy Cowsay. All right? Really? Ah, Felix is describing how to save the cows and to not squish them up into bubbles. Thanks, Felix. So anyways, this works for actually not just package resources. Any resource primitive that supports this can happen. So we actually don't have an AWS resource, which is quite sad. I would love to have an AWS resource in MGMT, for example, or Azure, or whatever cool cloud the Google people are selling these days. And if you think about it, making those API requests to the server, if they had a batch operation, we could actually group these together, not to make it parallel on my machine, but to save connection counts or other things. So the auto-grouping API really has lots of uses far beyond what I'm going to talk about today. Cool? You like this? Is this dope? Or, come on. So here's just some quick data I took. If you look, actually, this is just running Puppet, MGMT, and the raw package managers. Red is this really long thing. That's when you're installing 3 packages, so it's taking 2 to 3 times longer when you install them one at a time. So the grouping will actually save the environment, and you love the environment, right? Yes, CPU cycles, anyways. So we're actually very lucky today because we have Mr. Felix Frank right in the front. When I first talked about MGMT, I postulated that it would be possible, although perhaps a bit annoying, to write a compiler that takes existing Puppet code and compiles it so that it runs on MGMT, which would now make it run faster, in parallel, and with events and all of this magic. And it turns out, to my happy amazement, Felix actually wrote this, and it's beautiful. It's really fantastic. This is not the best example, but if you want to check this out, this works great. So if you had all this legacy Puppet code and you want to run it in a faster way, it's not perfect, but it's pretty damn good, and check it out. So just a quick plug. These are the resources we have in MGMT at the moment. It's not an exhaustive list of what we're going to build, but just to show you some ideas, we have all sorts of different kinds of resource, like password. What does that even do? You'll have to check my blog if you want more information on those. And we'd love for you to write your own resource. We have a resource guide. It's on GitHub. You can actually see how this works and implement the API. It's very simple and straightforward. So hopefully we can have some like heroes of new resources, cloud resources, whatever resources you want. So just ping me. I'm going to skip over this stuff. I want to show you some more demos. Do you want to see some more demos? Oh, right. We're warming up. Good. Sehr gut. So I have here a very simple resource which just declares the state of a virtual machine. So I'm going to go over here. If you see, I have one stopped Fedora 18 for some reason, old VM. No idea why. I'm just going to run MGMT on the left. You'll notice nothing's running as root here. And you see here, domain defined, domain started. You actually see, it actually started up a VM declaratively. So as I said, because we have this event system, we can actually do VMs, for example. And the cool thing is if I virt destroy that VM, you can see it started right back up. So same sort of thing. You can actually change the state of running VMs on the fly in milliseconds. So this is what I'm talking about, higher level resources. Use your imagination. What else can we build? I want to take this a little bit further. I'm just going to destroy this one. Oops. Undefine that. So I wanted to think about what a higher level design might look like. So I just need to check out a feature branch here called Cockpit. I'm just going to build a new version. And over here, I'm going to go into my browser. And there's this project called Cockpit. Type my password. I made a little Cockpit plugin for MGMT just to sort of simulate how this would actually work. And I'm just going to go down here. So what's going to happen is the sysadmins, I don't mind the squeaking. Anyways, it's all good. I will talk louder. What I want to show you is, suppose we have a higher level interface that the user wants to see. People like web UIs, people want to see like from the top of their whole cluster how we can actually make cluster-wide decisions and use these sorts of things. So I built this Cockpit plugin. What I'm going to first do is I'm going to actually just run MGMT right here. So MGMT is going to be running. See, that's working. Now I'm going to hide MGMT just because it's not as fun to look at as Cockpit. So that's hidden right here. And I'm just going to run right here. I'm going to run virt list in a little loop so that you can hopefully see, if my machine's not too slow, the real-time state of the VMs on the cluster. And now if you look right here, I have this slider. And as I move this slider over to 2, and I click save, it says, oh, 2 VMs are running. I can actually move this over to, say, 4. Click save. It'll change the new state to 2 VMs running. This is really happening on my actual shitty laptop. I can move it down to 1. Click save. 3 of them will shut down. Now here's what's happening every time I click save. Every time I click save, this shitty web UI plugin that I wrote pushes a new graph into Mgmt. So you got the currently running graph and the new graph. Then what it does an extremely efficient graph diff, looking at the old state and the new state, and then it runs that new graph, and because it knew that it was running continuously and it's watching the events, it knows that it only has to recheck things that are brand new or have some dependency that needs to be rechecked. So that graph switch can happen really, really quickly, and now you have a brand new run that sort of happened transparently. This is like running Puppet over and over again, or Terraform over and over again, except it happens really, really quickly. And when I mean really quickly, just to show you that I'm not lying, I had this little live checkbox right here. So now, as I move this in real time, you actually will see this actually is happening many, many times per second. Every millisecond or so, it's just going through. In real time, I'm actually changing the properties of my cluster. Is that cool? Now in this case, I'm just going to shut these all off. In this case, this is VMs. But this could have been something much more complicated. This could have been the state of your hybrid cloud, or different parameters that are really beyond my imagination. Just think of what you want to dynamically build, and then just declare the state of what you want, and the Mgmt engine will replicate itself and make it take you to that state. Is that cool? Do you want to see another demo, or are you fed up of demos? So I wanted to take this a little bit further. This one requires internet, so let's see if the internet's working. I need to SSH to my crappy, oops. First I need to SSH to my firewall, open up some SSH tunnels. So please stop torrenting if you're torrenting. This is a person who wants free help on the internet. Can't help them right now. So this is gonna be 2 windows on this remote server. It's actually a crappy laptop, but it's slightly less crappy than my current laptop. And I have a screen session running here, which I'm just going to open up in both windows so you can see what's going on. So on the right-hand side here, so on the server, on this laptop, I'm running Mgmt. Now on that machine, I've declared Mgmt, which is running right now, I just want to hide this, to create one virtual machine. And that virtual machine I'm logged into right here on the left. I can see it's a virtual machine, it's got 1 virtual CPU, and whoops, don't paste. And just to make this more fun, I'm going to run this command on that machine. So it's watching every half a second, it's running lscpu, and it's grepping the CPU count. Make sense? So I'm going to watch that just so you can see. Now watch this number right here, this 1. Over here, oh man, I'm like pasting like crazy. On that server, I actually made a crappy little shell script, which is basically like having that slider. So instead of having a slider in a web UI, I'm just have this shell script. And now watch what happens when I push the up button. You can actually see that the CPU count on that VM is going up or down. So in addition, in my virt resource, I declare, not imperatively, I declare the number of CPUs that VM should have. And Mgmt will look at that number, and if the number is wrong in the guessed, it will hot plug or hot unplug them for you. Is that cool? Just to show you what's actually happening, even if I go into the raw data structure, and I just change the CPU to 4, and I hit save, you see it really happens in under a second. So imagine now you have this cluster, it's managed by Mgmt, and boom, you got the load that goes up in your cluster. Now, in a millisecond, you could add CPUs to all those hosts and hopefully handle some initial buffering from the load that way, or something else. This is just an example. Whatever resources you want to build is really up to you. So I just want you to imagine what's possible with Mgmt. Do you like that? Have you had it with demos, or? I need a little bit more encouragement if you want to see more demos. I think they're quiet. That's it? Demos? No? Yes? You guys are very shy. I think you're possibly my most shy audience. So that's that example. If you want to see a few more demos, I got some time. I've got basically a half hour or so, right? Just under. Do you actually want to see some more demos, or do you have any questions? All right, thank you. So what I'm going to do, just to show you a demo that I skipped, is I'm just going to start up a vagrant VM. This will take a little bit of time because my laptop, again, is super old. We can actually even kill all -9 Firefox to get even more RAM. So I'm going to check out. No, Chrome is crap. Real hackers use Firefox. Come on. So I'm just starting up this vagrant VM, and I just want to check my notes for something. This is my set list. Okay. If you're listening at home, they're talking in German. I have no idea what they're saying. What? Oh, quietschen. All right, that's fine. I'll make fun of them in French later, so it's fine. Oh. So. Oh, wait. I think see if my lovely vagrant stuff is running. Okay. Let's just see if these VMs are running okay. I started them up in parallel, which is sometimes a little bit risky, but so this is VM1. That seems to be working. Thanks, vagrant. I'm just going to go here, and I'm going to just set some IP addresses because I really hate DNS. And this VM is running on IP address 42, which I'm just going to store in this file. Let's go into the second one. This is a little bit of setup, but more fun. So this is the second VM. Everything looks okay. You can see that this IP address is 251. Okay, I think we're good to go. Oops. Okay. Good. So here's a problem that I wanted to solve. So you have a data center. It's all beautifully managed. Config management tools right now. Your data center goes on fire, and this is bad because you play with fire in the data center, which you should not do. And your boss is very angry, but he has a very big charge card, and he gives you the charge card, and you buy like $10 million of new equipment, and you rack all of this stuff, which is great because you have a rack robot. And then you go in with your laptop, you plug it into a switch, you run some stuff, and within some amount of time, everything is built out from scratch, brand new. Whose infrastructure works like this right now? Raise your hand. We have one liar in the audience, and everyone else is honest, so that's good. Keep note of this gentleman. I'm joking. Maybe you have a really good system set up that can do this, but in general, this is a use case that we still haven't finished. Google even has like well-known problems with bootstrapping their infrastructure, and that's been a problem. So if we wanted to do this, it would be nice to have a tool. It would be nice to have a tool that runs on our laptop, which can remotely do some operations, and then get in there and replicate. And Mgmt actually does this. We call it remote execution, and I'm going to show you how it works. So what we do is we originally have Mgmt running. In this case, it's going to be on my laptop. And it will SSH, in this case, to these two VMs that I've ran, and then it will run that process. It will copy itself over. It's a single Golang binary, so that's quite easy. Copy itself over, and then it will run on those machines. The other thing that it does is, if you remember, we have this etcd traffic between the members in our cluster. So we actually tunnel the etcd traffic from those two remote machines through that SSH tunnel back to the host. So they can all communicate across etcd. They're going to converge, and I'll show you this in real time. So if you remember, we had that thing where we pushed the file up, and we pulled it back down. So we're going to run that same sort of example. Oh, man. Let's just do vscreen root at omv1. So let's just log into this first machine. You can see there's no files here. And I'm going to run this on the left. And on the right, you can see one of the VMs. I don't have room to show you both. Let's run this. Mgmt starts up. It copies the binary over. It pushes. And before I can even go over here, you can see now the files are actually created. If I actually cat these files, you can see that it has one file which it just created locally for fun. And it has one file from the first host and one file from the second host, because they pushed both those files up and then they copied each other's files down. That make sense? So let me just watch this. So you can actually see those files in real time now on the first machine. Okay? Now here's what I'm going to do. Just to make this really fun, I'm going to go in the graph definition of the second machine. So that's over here. So this is basically the definition of what that second machine should do. You can see here that it has a file, 2b, that it put in the database, and then the first machine pulled that file down from the database. Okay? So what I'm going to do is I'm going to edit this file here. I'm going to say, hey, NETWAYS, what is up? So I'm going to save this file in a second, but I want to discuss what's really going to happen when I press save. When I press save on my local laptop, Mgmt is going to notice that the configuration that I requested changed. What it's going to then do is it's going to push that file, that new configuration, over SSH to that second machine. The second machine is going to say, hey, I've got a new configuration. I'm going to run this new graph. It'll run that new graph, and in doing so, it's going to push that new data to etcd, basically back through that cluster. That other machine, that first VM, which is what we see on the left here, is watching etcd for new keys and changes and new resources that get stored in that database. Again, all over SSH. It's going to see now that there's an update because that second machine pushed that new file, and so it's going to pull down that file, which we are watching in real time. So it says, I'm file 2b exported from host B. All right? Is anyone confused on this? Because this is like the cool demo. So if you have a question, ask now before I press enter. Anyone confused, or does this make sense? Who is silent? Don't be shy. If you're confused, raise your hand. If you completely know what's going on, raise your hand. All right, so I think we've got some shy people. So I'm going to press enter and watch what happens. Boom. Happens very, very quickly. You like that? You can clap if you want. It's all right. All right. Okay, so what have I actually done here? Let's think about the implications. What I'm doing is Mgmt is running continuously, not using much CPU because it sleeps, of course. And now I'm actually just live editing my config and pushing it in real time to my data center. So I probably don't recommend you do this in production, but this might be very, very useful for testing out and building dev clusters, or if you're really brave, right? So you can just edit the things. You don't have to run puppet apply over and over again or wait. You just hack on the thing. If you break things, build a new cluster, and then hopefully you can do this quite safely. And also, it's quite useful for the remote execution case. Cool? So you can say whatever. Hey, burned, save it, whatever. Same thing, change it to whatever you want, different resources, whatever. Just one little bit to take this further. So as you can see, Mgmt is still running continuously, but I can actually kill it. Or you could have it, for example, take over and build itself and live a life of its own. But actually there's this converged timeout option, which was that same one I showed you in the beginning. Remember the converged timeout thing? So what it can do is it actually is going to run it, wait for the whole cluster as a whole to converge, and when that whole thing is converged, then shut down. So this is good for one-shot deploys that you don't want to continuously manage, and so on. So let's run this, and let's time it just to see how long this takes. So 5-second converge, runs, it copies the binaries over, it actually caches them if you want. Nothing's happening for 5 seconds, 2, 3, 4, 5, and the whole thing shuts down, and here it took 8 seconds. So 3 seconds of overhead to do all this operation. So yeah, cool? This is basically the drawing I did. Again, really shit at drawings. If you're bad at code and good at art, I'm bad at both, but send me a nicer drawing. Other ideas for this that aren't implemented. So this runs over SSH, and I showed you all this stuff. But if you wanted, you could actually build, as a next step, a hierarchical version of this. So imagine instead that the first machine SSHs to, say, 10 hosts, and then each of those 10 go to 10 other hosts or something like that. If you really wanted to do a crazy one-shot run or something like that, that would be quite easy to add to Mgmt. And if that's a feature that you'd like to work on, please ping me. It might be fun to do. It's actually useful for a completely other, different use case. Suppose you're like me, you're working remotely, and you're hacking in a coffee shop on shitty Wi-Fi, because I live in Canada. And your data center, it's obviously on like some fast local Ethernet, 10 gig or whatever. Your first hop of the remote executor could be into the data center, and then from there, that machine splays out to as many machines as you want. So that's another good use for the hierarchical design. Make sense? So just, it's a little bonus. Again, the distributed system is the main thing, but this is a little bonus that we built in because we thought it was a nice fit. So, a few other things. I'm going to just go to the end. I want to just sort of close, we'll ask some questions, and then if we have more time, we can look at a few more things if you're bored. I showed you the resource guide. We have in Mgmt the concept of metaparameters. So metaparameters are bits of code that are implemented in the engine, which is what I've been showing you. And in that engine, they can do magic things to any existing resource without you doing something special. These are what we have at the moment. We have auto grouping, which I showed you. We have a noop, so if you want to not touch a resource and just make sure that it applies, you can see what's going to happen, but not make any changes. Kind of like Puppet, we have that. If a resource fails, we can actually set a retry timer, that's the delay, and also a retry count, so try this forever, or try this up to 3 times and then permanently fail. If you really don't want to do the watch thing for some reason, you can actually use the poll metaparameter. So instead of watching live and detecting when something changes, you can say poll every 10 seconds or every 5 minutes or whatever you want if you really like. We have a limit and burst metaparameters. These use this weird computer science thing called a token bucket. So if you want to actually limit the events coming in so that you don't make changes to a resource more than 3 times per second or something like that, this can be quite useful if people are changing the environment very, very quickly and you want to just even out the load. And we even have a newer thing called a semaphore, and basically this is a lock. So in the graph you can say don't let more than 2 of these things run at the same time. So for systems that really are big or smaller systems that don't want to run 100 resources at the same time, you can easily add a semaphore to reduce the parallelism. I know, what a crazy idea. Or make sure that you only run this set of operations, but not at the same time as this set of operations. So if there's some dependency between the two. More ideas are planned, so if you have other things you want to work on, this could be fun too. A few other concepts. So Mgmt, it's written in Golang, and the code is actually written a bit like a library that has a very small front end with the CLI stuff. So you can actually take Mgmt, and instead of writing a whole management thing for your new piece of software, you can embed Mgmt natively into a Golang binary and use all of the built-in graph stuff and utilities for your management project. So you can use Golang to program the graphs, to describe the graphs, to describe the graph tangents, and a whole bunch of other things. One of the things we're considering doing at Red Hat is Red Hat has this gloucsterfs storage project, and I've recently joined the Gloucester and Ceph team, and they're working on a new replacement for the Gloucester management software, so that gloucesterd that's part of gloucsterfs. And one of the designs that I proposed is actually embedding Mgmt into the core of gloucesterd too, and that way you can actually describe what you want to do, all these operations as graphs, and hopefully this will be a good path to making the storage system autonomous and having it self-manage itself and so on. So if you're interested in storage and you want to help make Gloucester management really awesome, please ping me. I'm more than happy to talk about that. There's a few other things. I'm not talking about this today, but I have blog posts about it. Resources can actually accept and produce data along the graph edges. So this is actually kind of similar to what Terraform does, where it has variables that are produced that take data out, say the IP address of some AWS host you made, and push it into something else. So we have something called send receive, which if you're interested in describing things, this might be a cool thing to look into. This is basically to replace the kind of code you might have seen in Puppet, where you have a big exec resource that does like wget and pipes it to a file and so on, that sort of stuff. So something to look into. Future work. Mgmt is unfortunately not finished. I wish it was. When is software only finished anyways? But there's quite a lot of stuff to do. I've shown you these things. At the moment, to describe the graphs, we have these raw data structures which are in YAML. They're fairly simple. You can generate them. You can also use Puppet code to describe your graphs. But fundamentally, there's a much safer, better way to describe the graphs. And unfortunately, that involves a new language. There's some very good reasons why we can't use any existing language. And I'm very excited to tell you more about the language. It's just not ready yet. So this is a work in progress, but it is coming. So there will be a language, and hopefully you like it. The idea is to make it very, very safe, very easy to reason about, and so that you can actually describe these complex distributed systems very easily. So this is coming. If you love lectures and parsers and languages and reactive programming and functional reactive programming and all these cool things, please ping me. We'd love to have your contributions. New resources. We have a virt resource. There's always more things we could add to it. Hot plugging of memory chips, for example. We're working on an nspawn resource for containers. If you'd like to do that, or if you really like Docker or some other container thing, and you want to help us build a resource primitive for that. Network card resource to actually set up your network cards. All sorts of things are possible, even ideas I haven't mentioned. So if you want to build these, quite cool. You get like pro code evaluations for like sending your patches, so hopefully that helps you if you're not a Golang pro. There's some stuff we want to fix in the etcd clustering code. That's just random things going on. And there's lots of other things. Just to keep in mind, this is a community project. This is not a product. You cannot buy this from Red Hat. Please don't bug Red Hat to buy this because it does not exist. It's just an upstream, and hopefully I'll be a good mentor or steward of the upstream for now. So the language I talked about. This is about you guys. So how can you help? How can you help? You can use this. You can test it. You can patch it if you like sending patches. We have two great Mgmt contributors in the front, Felix and Julien, who's furiously writing a new Mgmt patch, I'm sure. So if you want to become famous like them, send patches. You can share this with your friends. You can document it. You can start on GitHub, purpleidea/mgmt. Start it. Show that you're interested in the project. You can blog about it. There's a nice group in France who didn't even tell me, but they did a little meetup and played with MGMT and wrote a nice blog post about it. So if you're into talking about your first experiences and telling your friends, do that. If you have Twitter, you can tweet it, discuss it, and just hack on this stuff. It's all about hacking good shit that we want. I have one marketing slide because Red Hat keeps paying me, and I'm glad that they pay my salary. So if you do want like to, give them money, please see them. They have all sorts of things that you can give them money for, and they're good. They're good to work for. So yeah, thanks Red Hat. Just to clarify though, again, this is an upstream community project. It's not a product, so I can't help you there. Let's just recap what we've gone through so far.
Answer. Now let me recap.
I don't know if you can see, it's just Arthur Benjamin putting the cap back on his pen. It's not funny. So a few links. There's the technical blog of James. Now you know about it. So next time if I see you at a conference, you don't raise your hand, you're in trouble. We have the GitHub page, purpleidea/mgmt. So if you want to check it out, all the code, docs, at the very bottom of the GitHub page are some videos to some existing talks, some of which have a lot of the same material, some covered in different ways and so on. So if I said something too quickly, go at the bottom, watch a talk. There's also a list of blog posts that I've written about each of these topics ad nauseum. So if you really want to drill into how one of these concepts work, go through the blog posts. They're in English, sorry, but hopefully they're understandable. And I'm on the internet. I'm Purple Idea. You can find me on IRC, on Freenode, on Twitter, GitHub, at gmail.com, at redhat.com. Don't be shy. Reach out if you want to get involved. And yeah, this is just some dumb slide I found on the internet because I do magic things sometimes. I need a big favor from you. So if you see, I'm afraid of pronouncing your name wrong, but if you see Bernd, he's one of the main organizers or the main organizer of this conference. And if you like this talk, I need you to help me coordinate a distributed denial service attack on him. I need you, after this talk, to take 5 seconds, go up to him and tell him, hey, I really like James's talk. I really like Purple Idea's talk. Do this, it will be a little hilarious, and he'll have like 50 people come up to him, which would be great. So if you have 5 seconds, don't send me a patch, but at least bother him. Cool? He looks like this. This is the internet's photo. So, please get involved. We have an IRC channel with about 50 or 60 people. MGMT config on Freenode. Join, hang out. I talk about secret things I'm working on, or not so secret, in the channel. So if you're there, you'll be involved. We have Twitter. We have like a bot and a hashtag if you're into tweetering. And we actually have a mailing list. It's extremely low volume. When there's MGMT stuff happening, mini hackathons. We had one in Berlin. Other stuff, new announcements, new releases. Join the list. Red Hat's hosting it, which is nice also, because finding hosting for mailing lists is impossible. So MGMT config, you can check that out as well. And that is the bulk of my talk. We have some time, so I want to. Oh, what did April says? Great talk. Yeah, I have like IRC stuff. You can like pop up messages if you want. So I want to take a bit of time for questions, and I think that's a good place to start in case you have any questions. Yes, the gentleman from HashiCorp, please. He's smiling. He was looking at his laptop a lot, but I think he was listening a bit in the background.
I listen
All right.
simultaneously. So I think this is really cool. Good job. Good talk.
Thank you.
My question is around like the edge triggering, particularly when it comes to like config changes for something that's not a package. Like say I change a config for my app and I push out a bad change. Is it possible to integrate, like you said about semaphores and kind of like splaying the push out, is it possible to integrate that with like a health check so that if, say I make the config change 2 at a time and those 2 now are unhealthy, can it just stop? Like kind of like a kill switch pattern.
Great question. I'm going to answer it in different levels. I think it'll be more comprehensive and you'll like it. So the first thing people say is like, oh, your tool is so fast, I can't control C it in time. To this I respond, that is stupid. If you really want it to be slower, we will add a meta parameter that you will write that will do an operation, wait 5 seconds, and then do another operation. So yes, I think fast is better. If that's bad, that's your mistake. In response to fixing that, that's why we're working on this language. One of the reasons is to make sure it's very, very safe. So by the time you push something, hopefully the compiler has stopped you from doing off by 1 errors and all sorts of dangerous things that you might have made a mistake on. Part 2. When you push this out to a cluster of machines, yes, that might go very quickly. Now, we're not at the point where we have the sort of deployment scenarios built yet. That's still in progress. It's not completely finished. It's not. The gentleman who was working on this had a child, and so now it spends time more with his child instead of Mgmt, which is absurd, but I at least can't fault him on it. So at the moment, that's a little bit on pause. So if someone wants to help build that out, we're more than happy to sort of have a splay sort of option, and that's totally up for discussion. It just isn't built yet because we're still quite new. Was there one other aspect that you wanted to talk about? Right. Yes, yes. So, all right, so what I wanted to say is, so the whole thing where, for example, like Terraform does this plan and tells you what it does, I think that's quite neat. I don't know if we're going to build something like that, but those sort of conversations I'm willing to have if people are really interested in doing the work. So we're very much open to all sorts of designs and ideas that I haven't built in there, but I have to prioritize the ones that are useful for me first. So if those things are valuable to you, we're more than happy to look into adding APIs to the resources for health and so on. We will probably be adding a status API, which will give resource level information for other things as well, which could probably be used for that as well. So we don't have something currently, but happy to talk about it, and please get involved. We'd love to collaborate with more people. Great questions. Any more who are not so shy? I won't tease you if your question is bad, unless your name is Felix. Gentleman over here in the snazzy t-shirts.
Thanks. I'm not sure what the scope of this is actually. So is it supposed to be a replacement for Puppet or Chef? Or is this more like, I really like the fact that you can embed it into your own programs. That's what I really like, but I'm not sure what the scope of it is.
Yeah, great question about the scope. So the truth is, the embedding into your own programs is, I think, an interesting use case, but I expect that that's probably 1% of all of the use cases. To get software authors who typically build distributed software and have their own management daemon that does cluster membership and all that stuff is a big hassle for those authors, and I think we could help them if they're interested. But that's, again, just a bonus thing that I think is cool, not the main thing. I don't want to talk about are we a replacement for Puppet or Chef or something like that. We're definitely in that space. I'm not looking at this in a competitive point of view because I like many of the Chef people, and I think this is a completely different tool. But I think for new generations of tools, we need this event stuff built in. It has to be a primitive, and so I just thought about what is the correct design for my infrastructure as code, and this is the tool that aims to solve that. There's a few more things planned that will be part of the tool, but probably that sort of thing. So possibly a combination of Chef, maybe Terraform, that sort of thing. But to be honest, when I started this, I didn't really know much about Terraform, for example. So get involved and help shape the tool the way you want to build it. Yeah, great question. Any more? I should mention, if I didn't mention, if you ask questions or you're really nice and you come up after and promise to use this, I have stickers which you can have. They're crazy expensive because the sticker cartels charge a fortune, but if you're going to stick them on your laptops, I will give you one. So don't be shy, ask a question or just come up and get a sticker anyways at the end. More questions? The gentleman over here.
Thank you.
You're welcome.
A bit daft, maybe. How about something like Hira in your new language? Because we use that quite a lot in our Puppet configs.
The Hira question is a great question. I've been thinking about this a lot. There's a few problems I have with Hira, Hira or whatever it is, based on the thing that I hate the most about Hira is how it merges the different layers together. I think that that is probably something that I would not want to implement. I do expect there to be some sort of way to have a YAML or XML or JSON file that puts the data into the top level resources and so on. We're not that far along yet into the language, so I don't know what it's going to look like. But if you want to be involved, please let me know and get involved in building out what that looks like. What did I want to tell you? That's most of it. Yeah, we will have some way of doing this. It's not coded yet, though. That's for sure. Good question. Any more questions? Shy. Don't be so shy. It's okay. I don't bite. I'm Canadian. I don't have any weapons, so it's like safe. It's not from the United States. Felix has a question.
Yeah, since you promised to burn me anyway, I think I can be the guy who gives an opinion and then masks it as a question. So, wouldn't you agree that the name Mgmt is a little unwieldy and makes it difficult to go? Yeah.
Who is a programmer here who is good at naming variables? Please raise your hand. Finally, they all.
He's going to call you a liar. Don't do it.
Yeah. No. I mean, I for like 6 months, I tried to think of a better name. Ansible is a great name, for example, but that's taken. I couldn't have used that. Hey, this is Ansible. No, it doesn't work. I'm sorry. It's why Mgmt config in Google or DuckDuckGo or whatever the kids use should find it. I'm sorry, Felix. It's short.
It's hot.
It's descriptive.
So if anyone has a good idea, that's James over there.
If you submit like a significant amount of patches and you have a different name, we'll consider changing it. But I'm not into renames at the moment. Sorry. More questions? We're basically on the nose.
Unfortunately, we don't have time anymore. Right. Sorry.
So thank you very much. If you want a sticker, come up and please get involved.
So James, thank you very much for this amazing talk.